Hello everyone, this is Amit, your mentor at mentorbuddy.com. Here we have a short video on pipes and cistern. So let's quickly see a question based on pipes and cistern. It says a larger tanker can be filled by two pipes, pipe A and B, in 60 minutes and 40 minutes respectively. How many minutes will it take to fill the tanker from empty state if B is used for half the time and A and B together fill it for other half? We have been given four options: A 15 minutes, B 20 minutes, C 27.5 minutes and D 30 minutes. We need to choose one correct option out of these. Okay, so before proceeding to this question, we'll just understand a concept behind it. That is a small concept of efficiency and timing equation. That is, it says, for example, if there are two pipes, let's suppose pipe A and pipe B, okay, and it is given that pipe A can fill the tank in 10 minutes, right? So pipe A, I can write it as fill the tank in 10 minutes, right? And pipe B can fill the tank in 15 minutes, right? The concept of efficiency says how to find the efficiency of pipe A and B. Efficiency means the amount of work done by pipe A in 1 minute and the amount of work done by pipe B in 1 minute. How to find efficiency? First of all, the basic thing is this. How we find the efficiency? We find efficiency by taking the LCM of both the timings. The LCM of 10 and 15 is how much? 10 and 15 LCM is 30. So we can write it as LCM as 30, right? Then LCM divided by the timing will give us efficiency. That is 30 divided by 10 will give me how much? It will give me 3. And similarly 30 divided by 15 will give me how much? That is 2. So the efficiency of pipe A is 3 and the efficiency of pipe B is 2. What does it mean? It means first understand the word efficiency. What does it mean? It means the how much pipe A is efficient to fill the tank in 1 minute. Okay, so if it is saying that how much pipe will be filled by tank A in 1 minute, that is 3. Okay, so how much tank will be filled by pipe B in 1 minute, that is 2. If the total work is how much? 30. Whatever we take LCM is considered as the total capacity of the tank, or we can say is the total work. How much work they have to do? See, filling the tank is also a work. I mean, the filling the tank is also a work. Like in a similar way we did in time and work, that if some man is doing some work, so here the pipes are doing the work. So whenever we take LCM is the total amount of work, or we can say the total capacity of the tank. Now you can cross verify it also. That is, if the efficiency of pipe A is 3, it means the amount of work done by pipe A in 1 minute is 3. So how much time it takes for pipe A to fill the tank? It takes 10 minutes. So in 1 minute, if it is doing 3 work, then how much work will be done in 10 minutes? 3 multiplied by 10, that is coming out to be 30, right? In a similar note, you can also cross verify it with the B, that if the amount of work done by B in 1 minute is 2, how much work will be done by B in 15 minutes? That is 15 multiplied by 2, that is also coming out to be 30. Okay, so it means the efficiency is what? Efficiency is the amount of work done by pipe A or pipe B in 1 minute. Clear? Okay, now if it has been given that if we are using pipe A for half minute, or we can say that pipe A for half the time and pipe B for another half, then how much time it will take in total? See, we cannot say that. See, in this situation, it has not been given us that what is the total timing, right? Total timing is not given us. So, and we cannot say that if it is 10 minutes and 15 minutes so together, because they are not doing, we can find out that how much time it will take together, but this is not the case. They are not doing together the work. They are doing half the time first pipe is working and another half time the second pipe is working. Okay, So in this situation, in this example, what I am saying, the question is that A is open for half the time and then B is open for another half time, right? So what will happen? So since we don't know the total timing, what we have to do, we have to consider the time as x. X is the total time for which both the pipes have worked, right? I mean x is the total timing in which the tank get filled, right? So pipe A worked for how much time? X by 2 minutes. And with what efficiency A works? A works with efficiency of 3. So how much work done will be by A? That is 3 multiplied by x by 2. Similarly, how much work done by B? That is 2 multiplied by x by 2, because B has also worked for half the time. And together, if they have filled the tank, then if we add the total work done by A and B, that should be equal to 30, right? Okay, so that should be equal to 30. So we can solve this equation, that is 2 will be cancelled out, and here we can say that it is equal to 1.5. so what it will become? 1.5 plus 1, it will become 2.5. so we can write it as 2.5x is equals to 30. So from here we got x as 30 by 2.5, right? So it will be equivalent to how much? That is 12 minutes. It means the value of x is coming out to be 12 minutes in this situation, right? When for half the time A has worked and half the time B has worked. So the basic concept behind this is that whenever we have any situation, we have to find the work, we have to multiply the time by efficiency to get the work done by any pipe, right? And if one pipe is doing this much work and another pipe is doing this much work, together they will complete the whole tank. That is the total work we have already find out, that is equivalent to 30. So that thing will be equal to 30. On the similar note, we will solve our question. Our question says that a larger tank can be filled by two pipes A and B together in 60 minutes and 40 minutes respectively. How many minutes will it take to fill the tanker from empty state if B is used for half the time and A and B together, right? A and B here, A and B together, fill it together for another half, right? So we have a situation in which A can fill the tank. From the first line we can infer that pipe A and B can fill the tank in 60 and 40 minutes. So A can fill the tank in 60 minutes. We can write it like this. B can fill the tank in 40 minutes. Okay. First step is to find the efficiency. How to find the efficiency? We need to find out the LCM of 60 and 40. The LCM of 60 and 40 is 120, right? So how much efficiency we get? Efficiency is equal to LCM, that is whatever is the LCM divided by the timing. So 120 upon 60 will give us 2. Similarly 120 upon 40 will give us 3. So the efficiency of pipe A is 2, the efficiency of pipe B is 3. Now what is given? How many minutes will it take to fill the tanker from empty state if B is used for half the time? Okay, so let the total time, or we can say let the total time taken be x, right? So half the time B has worked, so for x by 2, who has worked? B. So pipe B efficiency is 3. So how much work done by B? That is 3 multiplied by x by 2. Similarly for another half, A and B together is working. So together A and B, efficiency of A and B together is 3 plus 2, that is equal to 5. So with 5 efficiency, another half time, that is x by 2, they have worked. So both the pipes A and B together, how much work done they have done? That is 5 multiplied by x by 2. And this work, that is work done by pipe B alone for half the time and work done by both the pipes for half the time, should be equal to, if they have filled the tank, this should be equal to 120. Clear? Okay, so we can solve this equation. This is 2 we will cancel out, it will become 2.5x. 2 we can cancel out, it will become 1.5x. 1.5x plus 2.5x will be equal to 4x, equal to 120. So x will come out to be 120 divided by 4, that is equivalent to 30 minutes. Okay, so the time taken by both the pipes, I mean in this situation value of x is coming out to be 30 minutes, and we have taken x as the total time which we need to find, that is option D. So students, this is very important concept of efficiency which you should learn. This is a very fast and effective method. Okay, thank you.